Rightly so, many people are concerned about their greenhouse emissions. So I'm asking the question here, can I be meaner with our carbon? And by carbon I mean CO2 and the other greenhouse gases that we emit by our lifestyle. In this graph here we're showing CO2 emissions per person per year since 1850. Throughout that period, and indeed before that, the UK was way ahead of the world's average. You can see now it's dropping back to the world's average as the average across the globe is increasing. This is some good news for the UK, but also it indicates that we have not got there yet. We should not aim to be just at this world average. We should actually be aiming towards the zero line. Now this graph includes all greenhouse gases normalized towards carbon dioxide mass. It is only available for a more restricted time series, but you can see the rise has taken place and there is some flattening. It's not that this should be the end goal, but it indicates there is the potential for change. That is because even though the emissions may be levelling off, the accumulation of CO2 in the atmosphere is still increasing. Carbon dioxide lasts a long time in the atmosphere. The UK was ahead of the game in terms of creating CO2 from the mid-18th century, and so it's not surprising that its curve is a different shape to the world. The hope for stabilising temperature lies in being able to stabilise this accumulated CO2. To achieve that, we have to reach carbon zero in our outputs. I've adopted this graph from Climate Steward's Duplo model, which is an extremely good way of showing your carbon footprint. I've indicated a half a tonne of CO2 per year, roughly speaking, by one picture of our oil tank. As for energy, the three main expected uses of energy, air travel, heating and cooling, and our car, our surface transport, are shown here in terms of CO2 emissions. Larger items still are from what we eat and what we buy. This table shows CO2 equivalents in grams per kilometre travelled. Domestic flights have generally short spaces between takeoff and landings, which are the most expensive in terms of fuel, and so they can be seen to be the highest. That's about half a pound of carbon dioxide equivalents per kilogram travelled per passenger. Some lower figures for short and long haul flights, and these can be compared with alternative travel methods: national rail, a ferry passenger, and being a passenger on an electric international train. The alternatives here have a much lower carbon footprint. Surface travel by a single person in a car is not so dissimilar from a passenger in an aircraft. This can be reduced considerably by travelling by bus, and further still if you travel in an electric vehicle. Now the emissions associated with an electric vehicle will depend upon where you get your electricity from. And this figure here of 50 grams per kilometre travelled is associated to the UK grid. Finally, again, we compare these with national and international rail travel, which again show up as a lower carbon footprint. For our home energy uses, it all depends on the fuel we use. In terms of fossil fuels, natural gas has the lowest carbon footprint, and we've explained that in a related video. As you lower the hydrogen to carbon ratio in your fuel, your carbon load increases with the energy gained. We can see now that our grid electricity is similar to heating oil. One way to reduce your carbon footprint for your energy is to change to the use to electricity, and then to change to a green supplier. In our own household, we have changed to a heat pump from heating oil, changed to electricity for a kitchen range, and also maintained a green electricity supplier. So this was one day in the summer of 2020 when the oil tank finally went, and this is direct evidence of reduction in CO2 emission. So a large part of our CO2 footprint comes from what we buy and what we eat. So I've used this book from Michael Ashby, which is very helpful in providing information about the sustainability of the materials that we use. And using this to ask the main question, do we need what we want to buy? Because the answer to the question has the biggest impact on what our carbon footprint might be. This table looks at the energy, the carbon and the water footprint of 1 kilogram of material. The bricks, the concrete, the glass, the stuff that makes up much of our buildings, these are relatively low in carbon, energy and water use. When we look at organic materials, these values change quite radically. For softwood, the energy requirement is similar to that of glass. But the main difference, unsurprisingly, is the increase in the water required. For cotton, energy, carbon and water increase quite dramatically. And for wool in particular, the water demand is extremely large indeed. For polymers, the carbon footprint and the energy required is rather higher than the everyday items we looked at in the previous slide. One large difference is between natural rubber and synthetic rubber. The issue again is the larger amount of water required to make the natural material. The energy and carbon footprint of steel is not so different from synthetic polymers. Aluminium is rather higher for reasons we saw in the energy video due to the great difficulty in reducing aluminium oxide to aluminium. Copper, silver and gold have increasing demands for carbon, energy and water. It's not that any of these metals are particularly difficult chemically to get to the metal state. It's just the energy required to extract them and purify them. And for gold, you can see this reaches an extremely high value. So a kilogram of gold requires more water than a kilogram even of wool. The carbon footprint of what we eat varies considerably with the diet. It can also be seen that the water demands for meeting this particular diet also changes quite dramatically. So indeed what we eat does have an impact on what our carbon footprint is. And the next biggest decision for your carbon footprint is, having got this material, can I reuse it? This is a Danish study about grocery shopping bags. The standard item here is one low-density polyethylene as a normal kind of plastic bag. Another one is a polypropylene bag of a woven nature, a PET bag, a standard cotton bag and an organic cotton bag, and finally a jute polypropylene cotton hybrid mixture. In terms of the embodied carbon, there was a factor of about 100 difference between the smallest and the largest. And in terms of virtual water, the factor was even larger. When all the environmental factors were taken into account, it was estimated that the organic cotton bag would have to be used 20,000 times to have the same impact per use as the standard plastic bag. So we have to be very careful about what we choose for materials and how many times they're going to be used. So some materials do have to be reused many times to be worthwhile. But the next question is, after their life, can I recycle it? Considering the amount of energy required to make these materials, it's not surprising that the footprint broadly follows the same lines. There is a very large reduction in the carbon footprint that can be achieved by using recycled material of both aluminium and stainless steel. It's very important that for many metals we have the right infrastructure to be able to collect, separate and recycle them. In a report from Carbon Brief that I've seen today, we were roughly halfway towards reaching a carbon zero output for the United Kingdom. That's in terms of our greenhouse emissions. And that's been helped substantially by the conditions during the pandemic. As that eases, the question is really how much of that can be maintained and how much of it can be improved still further. So if I look at my version of the Carbon Stewards Duplo carbon footprint, which is very useful for assessing how you can offset your carbon by using Climate Stewards, we can see what inroads we might be able to make with this in these circumstances. As I indicated in the energy video, our air travel over the last 3 years has been 0, so we can obliterate that one. We might claim now that our energy footprint of our home energy is extremely small, so in fact I'm going to approximate by saying that is 0. Our car use and other surface travel has decreased enormously, just like it has for other people, so I'll drop that back down to 1 unit here. Our food has reduced, we've lost weight. So again, this will mean there is a reduction in our carbon footprint. We've also switched to a more vegetarian diet, and because of the time we've been able to have at home, in fact increase the amount of food that we've made in our own garden. And finally, we have bought somewhat less stuff. So the diagram I'm showing now is an indication of where I think we are towards a carbon zero lifestyle. There's still a way to go, and that's what we'll have to work on in our coming years.